with your hand.
Yeah.
Yes. You see, left ventricle is actually the same way. Yes. You see, squeeze it like this. Squeeze it like. I will discuss it later. See, squeeze it like this. Even if you squeeze the cloth, some water is actually left. See, this is called potential.
Sir, potential energy is an energy in which gravity is involved.
You are not. No. This is not physics. You are talking about pressure and volume, not the distance and force.
But you mentioned potential energy.
So this is potential energy.
So there is no gravity. There is no involvement of gravity. Why we are calling it potential energy?
When there is volume, there is energy. When there is volume, there is pressure. Am I right?
Yeah.
When there is volume of a liquid, there is a pressure inside.
So we can relate it to the kinetic energy because it has volume, it has pressure.
No, when it is moved, it is kinetic energy. It is not moved, it is left in the left ventricle. Since you cannot move it, this is called potential energy. When do you use it? In a strenuous exercise.
So short pressure creates energy.
Did you get it? Have you ever seen how a skeletal muscle contract? Have you ever, in a lab or in a film, in a video or something like that? In physiology department, we take gastrocnemius muscle from a frog and connect it to a force transducer or pressure transducer. You see, we have two types of contraction. Listen. This is a hook. This is the gastrocnemius muscle. This is another hook. Above, we have a pressure transducer. You can contract a skeletal muscle like a cardiac muscle via the nerves. You can stimulate the nerve that is coming into the skeletal muscle or the muscle belly itself. If you have a microelectrode, put it in the belly of the muscle and apply a stimulus, an electrical current to the muscle will be contracted. Like this. We have two types of muscle contraction. Isometric and isotonic. Two types. In isometric contraction, we can use, which you can see here, in isometric contraction, the muscleness doesn't change, but the tension inside it will be increased. And you can measure it via a pressure transducer. This is called isometric. The both ends are fixed with two hooks. But here, if I connect pan of weights to one end and contract the muscle, the load, these weights will be lifted up and the muscle will be shortened. This is called isotonic contraction. We have two types of contraction, isometric and isotonic. See on this figure, see in this figure, here we have isometric contraction. The cardiac myocytes doesn't change their length, but the pressure or the tension inside it will be increased. But here,
Contractions.
isotonic
Tonic.
contraction. The cardiac myocyte
Change
will be
volume.
reduced and the blood innovates. Will go out from there. So you have two types of muscle contraction here in the heart. Isometric, Now you tell me here which part? Isovolumetric or isotonic? Which part needs more energy?
Tonic, isotonic.